Good afternoon. I'd like to start by thanking the BBVA Foundation and AEOS for inviting us to take part in this event. I'll introduce myself while they put my slides up. Could you go back? Okay, it doesn't matter. My name is Emilia Gómez. I'm a telecommunications engineer, also a pianist, but very poor. Definitely a better engineer than I am a musician. I work on research about how technology can be applied to music. Specifically, I coordinate the Fenicex project, which is funded by the European Commission, part of the 7th Framework Program, where over 30 researchers from different institutions have taken part. There you have a list. These are institutes, mostly technology institutes, that have worked with music, particularly other genres, pop music, where a lot of specific technology has been developed, and two music institutes, an orchestra, the Conservatoire Orchestra of Amsterdam, plus an education institute open to experimentation, where we try to face the challenge of seeing whether technology can serve to improve the concert experience, what the scientific and technological challenges are in this area, and that's what I'm going to try and show you in this talk. If I can find the right button. Okay, so the question we asked was, can music technology serve to enhance the way in which we experience a performance? In this case, we have already spoken about how to improve the listener's experience, so that's our goal in this project, to focus on the audience, not the musicians. Although we do also have projects for musicians, and the goal is the same that you've heard in the previous talks, to try and minimize the barriers in the performance, that is, moving on to the digital formats, also minimizing social barriers by adapting the experience to different target groups and different profiles, and to try and decrease the distance that can exist in this type of genre between the performer and the listener. That is, how to make sure that the audience is not just passively sitting, but rather actively participating in the performance. We have these conceptual challenges, but we also have a lot of research issues, because classical music has not been really covered by image or signal processing technologies. Symphony music is particularly complex because of the many instruments. Musically also, these are much more complex structures and longer pieces. Plus, in a concert, you have to work in real time, as we say in technology. You can't spend 3 days processing data. So these were the challenges that we faced. And the concept for the project is for the concert to become a digital object, a multimodal digital object. What that means is that the object is not just a listening experience, it's also a visual experience. We have information about the score, we have texts of reviews and the program, plus the performance can be experienced from different perspectives. We can watch a concert from the back of the hall, or the best seats in the house, or we can watch it from the worst seats in the house. And we can also experience it understanding and knowing a great deal about the piece, or from the perspective of a viewer who knows very little about the performance at all. Plus, there's information about the work which is being performed, information about the musicians that are performing it, and also social information connected to the historical context of the piece. And we try and combine all of that within our digital object. And this concept of a digital object is not new. There are a lot of other researchers working on this issue, and I'm going to show you a video, if we can get it to play, with an app which is called AEOS Editions.
Concertgebouw Orchestra is proud to present RCO Editions, a unique video magazine for your iPad, packed with recordings of stirring concerts, expert commentary, inspiring articles and video clips. Download the free app for instant access into the world of the Royal Concertgebouw Orchestra from the comfort of your own home. RCO Editions. Feel it at home.
Okay, so with this concept of the performance as a digital object, performance may be enjoyed before, during, and after it actually takes place. In our project, we have focused on 7 cases. It's a research project, so we don't yet have an app. We have prototypes, and we have guidelines which could potentially be useful for the following 7 cases, which I'll try and explain in a bit more detail. The first problem we dealt with was how to store all the data connected with the performance. If we ask how much data Beethoven's Third Symphony represents, you could be told that there's a very large number of microphones, plus there's a lot of cameras, plus there's the score, plus all the information about the performers, and all of this requires a data repository that can be accessed online, which can be organized, synchronized, and documented, and that's the first challenge we had to deal with. In this project, we created a data repository, which is an online resource where we can store data, but also access the data, not for the end users, but in order to edit them. And I'll show you a brief video of how this platform works. If you can please run the video. They will show you an example of the types of data we can store. You can store audio, video, files. You can also store the score. But in this research project, we even stored EEG signals from the musicians' brains. Any type of data that can be useful for research or development can be synchronized and should be stored in an organized and synchronized fashion. You can stop the video now. How can we use this data? Well, the first case we considered is the before the performance. Continue with the same example, Beethoven's Third. I don't know whether you can imagine all the analysis that's on the internet, all the programs of related performances you can find in the internet, critical reviews, and also, of course, recordings, videos, films about this symphony. How can we create an adapted digital program? In our case, you can't really see it very well in the picture, but we retrieve all of this data using systems that seek data on the internet and filter it. We use the social networks to personalize that content for each user. And I still don't know what button I'm supposed to hit to get to the next slide. But for instance, you can't see it very well here, but somebody who accesses the system can specify how much they know about music, whether they're familiar with the piece that they'll be listening to or not, and they can contribute data so that their program can be customized. Another case would be to visualize the music. You can visualize the music during and after the performance. Why? In order to understand it better. In this sense, first thing you could do is look at the score. There are systems where, as you listen to the music, show you where you are on the score. And so we developed technology to do that in the project. Let's see that video. This may seem easy, but it's actually really difficult for the software because it has to identify the notes that are being played, search for them on the score, and to do this almost instantaneously. Then you can stop the video now. You can also look at other things, not just the score. For example, people who can't read music do not want to see the score, but would rather get information about the structure of the piece. No one will entirely agree with what the structure of a piece is, but to have some idea of what that structure might be. And a lot of our users wanted to know also when they were meant to upload. And so in this case, we adapt the viewing to each user's profile. I'll show you a different video now. I'm sorry that this is going very slow because of the videos. Could we watch the next video, please? And here you'll be able to see the information about the instruments that are playing at any one point, and you can map that with some lights. Can we run this video? I guess I brought too many videos. Okay, so I'll just move on, and if you're interested, I can give you some additional information later. Other examples would be focus, where we try and develop technologies for after the performance, where you will, for example, be able to listen to each separate instrument. To do that, we process the audio and the video so we can separate the different instruments in the orchestra and identify in each image what instruments are performing and when they're being used and when they're not, so you can zoom in on the video and also the audio. I'm going to skip the video because I'm running out of time. And the next examples are compare performances, because there are very many different performances in this particular symphony orchestra of the same piece, and there's also many performances by different orchestras. Using artificial intelligence techniques, we can compare how different symphony orchestras perform a particular piece, using descriptors like tempo, dynamic performance, and so on. And the second to last example is called Capture the Moment and Share the Magic. In this case, we use tools that enable you to capture a moment using mobile technologies. Here we have an example with the same symphony orchestra where the audience can tell us what moment they found more fulfilling or more exciting, and we can connect that to certain characteristics of the piece musically and also visually. And we can analyze data from one of the editors or from the audience. And finally, we have the concept Join the Orchestra, which is a way to study the conductors or the performers' gestures. In this case, we work with conductors and also trainers who will help us develop technology or educational tools so you can learn to conduct a symphony orchestra. similar to what we heard in the previous talk. In conclusion, to finish, and I'm sorry that it took a little longer than expected because of the videos, we tried to use the benefits of technology in order to try and preserve, enjoy, and relive a performance. And we have a first prototype, and we already have some research outcomes. And now we're assessing with this orchestra's audiences, as well as students and musicians, the results of the program. In the future, we'd like it to have more interactive features for instance, children or young people. We're also looking at how to adapt the performance to people with some degree of hearing loss. And we're also going to focus on the musicians, how these technologies may help the musicians in their performances by helping them manage the score, or also for a useful rehearsal tool. And finally, of course, there's educational applications. And if you give me a minute before the next speaker comes up, I'd like to finish by showing you video number 7. Pues hola.